How can I imagine this? Your wonderful lifestyle reaches the DNA in each of your cells. How does that work?
Well, let's say you are fasting or on a calorically restricted diet, so you're eating 20% less than the calories that your nutritionist or doctor would recommend. What happens then is a lot of things. One of the things that happens is you'll have lower blood glucose. You're getting less glucose attaching to proteins. It's called glycation. You're also turning on longevity genes, such as sirtuins, which are 7 genes in the body that we work on. And the sirtuins control the body's defenses against aging. They are epigenetic information regulators. Actually, sirtuins stands for silent information regulators, so it's in the name. They protect and stabilize the epigenome. They also repair broken chromosomes, so they do those 2 important jobs. They delay senescence. They improve the body's sensitivity to insulin, so you get better blood glucose levels. They ramp up mitochondria, and they do all these things. There's whole thousands of papers on this topic, but the way to think about it is that when your body is in a state of adversity, like it's not getting enough calories or not getting enough protein or certain amino acids, it'll turn on these defenses, and they will turn on the very proximal downstream, we call it, defenses, like repairing DNA and turning on energy and stopping inflammation. And so that's really what's happening at the molecular level. There's a paper that's coming out shortly that has found a molecule that the body makes itself, that's in the gut, that can turn on the sirtuin defenses. It works very similar, if not identical, to resveratrol, one of the molecules we discovered back in the early 2000s that you get from plants. You get it from grapes and can get it in red wine or supplements. But somebody that's going to publish soon has found that there's a natural molecule that we make ourselves that turns on sirtuin. So that's also something that happens when we're hungry, which is an exciting new development coming out.
And you can measure what is happening on your DNA with the epigenetic clock. And there are so many people who are now buying them in internet. Which is it really useful to use them? And there are so many. What can you tell our readers?
Yes, I would say they're useful to see progress over long periods of time, over 6 months to a year. And they can be used as guides for clinical trials to see if aging is affected. But you can't easily compare one test to another. They're all quite different, as you alluded to. We developed one in my lab that's a cheek swab test that you can get, at least in the US. And there's lots of others. There's blood tests as well. There isn't one test that's better than all of them. There's Dunedin Pace, there's Tally Health, there's True Age. There's a few, and there's others, of course, in Europe. But I would say that you could pick one and stick with it for a year or so and have a look how you're doing. There's going to be some noise, right? Because even if you run the same test twice, you'll get a slightly different answer, 5-10% variability. But it's the long-term changes that you want to see. And so I've been doing similar tests, not DNA methylation, but blood tests for biomarkers with a company called InnerAge. Actually, the company's called Inside Tracker, but the test is called InnerAge. I've been doing that for probably 14 years now. And, one test to another is not as revealing as looking at it over years to see if, am I going in the right direction? Is it negative or is it positive? And so that's where we're at. I wouldn't say we're at the point where doctors could diagnose something with one of these tests yet. It's like early AI. It's going to be useful, but we're still working on it.